Hello students, let us continue the session on triangles. Today's session we shall solve exercise 6.4. It's the last exercise of the chapter. First question is in figure 6.16. If angle A equal to angle C and AB equal to 6 cm, BP equal to 15 cm, AP equal to 12 cm and CP equal to 4 cm, find the lengths of PD and CD. Let me mention the sides here. AB is given as 6 cm, BP is given as 15 cm, AP is given as 12 cm, CP is 4. We need to find the length of PD as well as the length of CD. Suppose if I consider the length of PD as X and CD as Y, look at the triangles. In triangle ABP and triangle CDP, we have got angle A equal to angle C because it is given. Just observe there are two vertically opposite angles, angle APB equal to angle CPD. These are vertically opposite angles. Whenever two pairs of the angles are equal, we can say that the triangles are similar by AA similarity. Whenever the triangles are similar, then the corresponding sides are in proportion. So the corresponding sides AB upon CD will be equal to AP upon CP. This will be equal to BP upon DP. Now, by substituting the values, AB is 6, 6 by CD we have taken as Y, which is equal to 12 upon the side CP is 4. This is equal to 15 upon X. Now if I consider these two equalities, I'll get the value of Y. Y will be equal to 6 times 4 divided by 12. We get it as 2 cm. And by taking this equality, we get the value of X as 15 times 4 upon 12. 3 4 times is 12, 3 5 times is 15. 4 will get cancelled, we get it as 5 cm. So the length of PD is 5 cm and the length of CD is 2 cm respectively. Second question. It is given that triangle ABC is similar to the triangle EDF such that AB is equal to 5 cm, AC is equal to 7 cm, DF equal to 15 cm and D equal to 12 cm. Find the lengths of the remaining sides of the triangle. Let me first mention what the sides given. Let me consider the two triangles. The triangle ABC, it is given that it's similar to the triangle EDF. So with respect to A we have got E, with respect to B D, with respect to C F. The sides given are AB 5 cm, AC 7 cm, DF is 15 cm, DE is 12 cm. Let me name the unknown sides as X and Y. Since they have given that the triangles are similar, triangle ABC is similar to the triangle EDF, the corresponding sides are in proportion, the ratio AB by ED will become equal to AC upon EF. This will be equal to BC upon DF. AB, the length is 5 upon 12. This will be equal to 7 upon Y. This will be equal to X upon 15. Now I can find the value of y as 7 multiplied to 12 upon 5. We get it as 84 by 5. We get in terms of decimal 16.8 centimeter. And the value of x will be equal to 5 multiplied to 15 upon 12. This will be 25 by 4. The reason is it is divisible by 3. We get 6.25 centimeter. Therefore, the length of the remaining side BC is 6.25 and EF is 16.8 centimeter. Question number 3, it's one of the important question. Prove that if a line is drawn parallel to one of the side of triangle to intersect the other two sides, then the two sides are divided in the same ratio. This particular thing we have done, this is same as the Thales theorem. So sometime in the examination they may give the statement, or else they may ask state and prove Thales theorem, or else it is also called as basic proportionality theorem. What we had done, we had taken the triangles ratio, their areas, and we have taken in terms of half base into height. By doing construction, we had two altitudes. Then we have taken the ratio to be equal. So in this particular thing, we need to prove. To prove is the sides are divided in the equal ratio. AD upon DB equal to AE upon EC, provided we have the triangle like this, ABC, and there is a line drawn parallel, DE, let it be the line which is drawn parallel to BC. What we had done is, we had joined this BE and DC, and we have taken the altitude for both the triangles. You can refer back to the previous videos. This particular thing has been done. Let's see the next question. Question number. In the figure 6.17, PQRS inside, it's a parallelogram in which AB, the outer one, AB is parallel to PS. Then prove that OC is parallel to SR. To solve this, I require some angles. So I'll mention those angles in terms of the numbers. Let me name this as angle 1, this as angle 2, let this be angle 3, let this be angle 4, let this be angle 5, let this be angle 6, not this, let this be angle 6. What we need to prove? We need to prove that OC is parallel to SR. What I am going to do is, I'll consider some parts of the triangles here. One of the triangle, take OAB and triangle OPC, sorry, OPS and OAB. A smaller one, the larger one I am taking. Now observe, since AB is given parallel to PS, AB is parallel to PS, we have got angle 1 equal to angle 2. At the same time, angle 3 will be equal to angle 4. These angles are the corresponding angles. Whenever the corresponding angles are equal to pairs of corresponding angles are equal, by AA similarity I can say the triangles are similar. This is by AA similarity. When the triangles are similar to each other, their corresponding sides are in proportion, so I can say that OP upon OA equal to OS upon OB. This will be equal to PS upon AB. Let me name this as equation 1. PQRS is a parallelogram. Since it is a parallelogram, opposite sides are parallel to each other, PS will be parallel to QR. Let me name this as the equation 2. And also QR will be parallel to AB. Let me name this as equation 3. From equation 2 and 3, I can say PS is parallel to AB. Now this is already given, so let it be. Now let me consider the triangles. In triangle CQR and triangle CAB, we have QR parallel to AB. Since QR is parallel to AB, angle CAB is equal to angle 5, angle CBA equal to angle 6. These two are the corresponding angles. Therefore, the triangle CQR is similar to the triangle CAB by AA similarity. When the triangles are similar, the sides are in proportion. This implies CQ upon CA equal to CR upon CB. This is equal to QR upon AB. Since PQRS is a parallelogram, in this parallelogram, PS will be parallel to QR and PS will be equal to QR. So instead of QR, I can substitute PS. So this will be changed into PS upon AB equal to CR upon CB. This will be equal to CQ upon CA. Let me name this as equation 4. Observe equation 1 and equation 4. In the equation 1 we had OP by OA equal to OS by OB equal to PS by AB. In the equation 4 we have PS by AB equal to CR by CB, which is equal to CQ by CA. So I can write CR by CB is same as OS by OB. These two ratios are equal. This implies that in triangle BOC, in triangle BOC, by converse of basic proportionality theorem, SR will become parallel to OC, hence proved. Question number 5. A 5-meter long ladder is placed leaning towards vertical wall such that it reaches the wall at a point 4 meter high. If the foot of the ladder is moved 1.6 meter towards the wall, find the distance by which the top of the ladder would slide upwards on the wall. Here, the situation is like there is a ladder placed leaning towards the wall. If I mention this wall to be say LW and this as some D, D represents the DL represents the ladder, which is 5 meter, and this ladder is leaning towards the wall and it reaches the wall 4 meter. From here to here it is 4 meter. Now this wall, from the base it is taken towards the wall till 1.6 meter. Let it reach the point R. Now it slides upwards. The ladder slides upwards and it reaches some point, say E. We all know that the length of the ladder will remain same. It is 5 meter. We don't know this particular length. EL is not known to us. RW is the remaining distance from the wall. They have given that 5 meter is the length of the ladder, 4 meter is the height where it reaches in the beginning stage, and the ladder is moved 1.6 meter towards the wall. Rest of the things are not known to us. Then how do we make use of Pythagoras theorem here? Just observe, we have got a right angle triangle LWD. It's a right angle triangle. With this right angle triangle, I can find out the length of the base, means the distance of the foot of the ladder from the wall we can find. So in triangle LWD, we have the hypotenuse as DL. So square on the hypotenuse, DL square will be equal to LW square plus DW square. So I can find out DW square as DL square, which is 5 square, minus LW square, which is 4 square. 25 minus 16 is 9. So I can find the length of DW. It will be 3 meters. So DW is 3 meter. So we can find out DW as the sum of dr plus rw. So rw will be dw, which is 3 minus dr, which is 1.6. We get it as 1.4 meters. Now in triangle RWE, again we have got right angle. The hypotenuse will be RE. RE square will be equal to RW square plus LEW square. Sorry, this is EW, yeah, EW square. So EW square will become equal to RE square, which is 5 square, minus RW square is 1.4 square. So EW square will be equal to 25 minus 1.5 square is 1.4 square is 1.96. So EW will become under root. The difference is 23.04. 5 square will be 25, so it should be the number greater than 4, between 4 and 5. So the last digit is 4 here. If you check 4.8, probably it suits. Yeah, it suits. So EW is 4.8 meters. The question is to find out the distance by which the ladder is shifted upwards. Therefore, the distance by which the ladder is shifted up will be EL. This will become EW minus LW. This will be 0.8 meter. 4.8 minus 4 will be 0.8 meters. Question number 6. For going to a city B from city A, there is a route via C such that AC is perpendicular to CB. So it forms a right-angled triangle. is something like point A, point C and point B. AC, it is 2x kilometer. BC is 2 times of x plus 7 kilometer, and it is proposed to construct 26 kilometer highway, means the straight line AB is 26 kilometer. Find how much distance will be saved reaching the city B from city A after constructing the highway. So this 26 is the highway, 26 kilometer. We need to subtract this from the sum of these two sides. So what do we do? Distance saved will be AC plus BC minus AB. Since AC is given perpendicular to CB, we have got a right-angled triangle. In this right-angled triangle, AC square plus BC square will be equal to AB square. AC, the length is 2x whole square plus BC square is twice of x plus 7 whole square, which is equal to 26 square. Let us further simplify this. This will become 4x square plus this will be 4 times. The inside one also should be squared. We get x square plus 49 plus 14x. This to be multiplied with 4. This will be equal to 676. 26 square is 676. On further simplification, here there is 4 common. We get x square added to x square plus 49 plus 14x. This is equal to 676. This 4 can be transposed to the other side, or else divide both sides by 4. We'll be getting 2x square plus 14x plus 49 equal to 676 by 4 is 169. On further simplification, we get 2x square plus 14x. This should be transposed to the other side. We get negative 120 equal to 0. Throughout there is 2 common. So x square plus 7x minus 60 equal to 0. 12 5 times is 60. Positive 12 and negative 5 would work. So we get the result as x plus 12 multiplied to x minus 5 equal to 0. Therefore, the value of x is either negative 12 or positive 5. This negative 12 is rejected because the distance cannot be negative. Therefore, the required distance will be 2x plus 14 minus 26. On further simplification, we get 4x minus 12, which will be 20 minus 12, 8 kilometer. By constructing highway, the distance reduced will be 8 kilometers. Question number 7. A flag pole is 18 meter high, cast a shadow 9.6 meters long. Find the distance of the top of the pole from the far end of the shadow. Suppose if I consider the pole to be some PL and it is casting a shadow, say yes. Alright, the pole height is 18 meter, it's casting a shadow 9.6 meter. We need to find the distance PS. It's pretty simple. We have to use Pythagoras theorem. Square on the hypotenuse will be equal to sum of the squares of the remaining two sides. So 9.6 square plus 18 square. So PS square will be equal to 9.6 square is 92.16 and 18 square is 324. We get PS as under root 416.16. We need to find the square root of this. Follow division method, you will get it in an easier way, and the distance is 20.4 meters. Next question is, a street light bulb is fixed on a pole 6 meters above the level of the street. If a woman of height 1.5 meter casts a shadow 3 meter, find how far is she away, how far she is away from the base of the pole. I will represent this situation using the figure. Let me mention the pole as a PL and the woman as say WN, woman, and she is casting a shadow at point S. So 3 meter is the length of the shadow, 1.5 meter is the height of the woman, 6 meter is the pole. How far is she away from the pole? We need to find this particular distance. If you observe, here we have got two right angles and this angle S is being common, so I can say that the triangles are similar. If you consider triangle NSW and triangle LSP, we have got angle W equal to angle P equal to 90 degrees, angle S is equal to angle S, therefore the triangle NWS, the corresponding sides I am writing, is similar to the triangle LPS. With respect to P, we have got W. Alright, when the triangles are similar by a similarity, we can consider the corresponding sides ratio. So LP upon NW will be equal to LS upon NS. This will be equal to PS upon WS. We need to find the value of X. So remaining I'll substitute. This will be equal to, this length of PS will be 3 plus X. The length of WS is 3. With this, I can find, multiply 1.5 with 3, we get 4.5 plus 1.5x, which is equal to 18. So 1.5x will be 18 minus 4.5, which is 13.5. So the value of x is 13.5 upon 1.5. We get it as 9 meter. With these 8 questions, I will complete today's session. Remaining question we shall see in the next session. Thank you.